It started as nothing more than a flicker in the data, a cold, silent speck moving far faster than anything that should have been out there. But then, the James Webb Space Telescope captured the first real image of 3Y Atlas, confirming its presence and reigniting debates about its origin. Now traveling at 152,000 miles per hour from the depths of interstellar space, this mysterious visitor is rewriting what we know about cosmic travelers. The flicker in the data. The flicker in data that led to the discovery of 3Y Atlas was first noticed by astronomer Larry Deneau using the Atlas survey system in early 2025. Initially, the object appeared as a faint point source barely distinguishable from background noise, traveling at an extraordinary speed that defied expectations. Rapid follow-up observations from telescopes worldwide confirmed its hyperbolic trajectory, indicating an interstellar origin beyond our solar system. The discovery highlighted the increasing capability of modern automated sky surveys and the importance of advanced image processing techniques in spotting elusive cosmic phenomena. 3I Atlas's initial data sparked excitement and mystery in equal measure, leading to widespread international scientific collaboration to understand its true nature. The detection demonstrated the effectiveness of coordinated astronomy projects working in concert across hemispheres to capture fleeting interstellar visitors. What began as a mere computational anomaly quickly evolved into one of the most significant astronomical discoveries of the decade, challenging our understanding of what travels through the void between stars, and forcing scientists to reconsider fundamental assumptions about interstellar objects. 152,000 mph from the void. Moving at an incredible velocity of approximately 152,000 miles per hour, 3Y Atlas stands as one of the fastest objects ever recorded within our solar system's boundaries. Its extraordinary speed distinguishes it from typical asteroids or comets native to our cosmic neighborhood, definitively confirming its extragalactic origins. The precise velocity measurements were obtained using combined data from the Hubble Space Telescope and ground-based observatories worldwide. This phenomenal speed suggests a trajectory completely uninfluenced by our sun's gravitational pull, affirming that 3I Atlas is truly a visitor from another star system. Scientists involved in tracking the object, including Dr. Davide Farnocchia at NASA's Jet Propulsion Laboratory, are racing against time to gather detailed observations before it disappears forever into the cosmic void. The object's rapid passage through our observational field poses unprecedented challenges for data collection, requiring lightning-fast coordination among observatories globally to maximize information retrieval during its brief transit. Such extraordinary velocity raises fundamental questions about the forces that accelerated this object to such speeds and whether natural processes alone could account for its remarkable journey through interstellar space. 3 visitors, 7 years. Over the span of 7 years, humanity has documented the arrival of 3 confirmed interstellar visitors: Oumuamua in 2017, 2I Borisov in 2019, and now 3I Atlas in 2025. Each visitor has brought unique characteristics that challenge our understanding of interstellar objects and their origins. Oumuamua puzzled scientists with its cigar-like shape and unexplained acceleration, while 2I Borisov displayed traditional comet behavior with visible outgassing. 3Y Atlas represents perhaps the most enigmatic of the 3, combining unprecedented size with unusual physical properties. The increasing frequency of these detections suggests either improved observational capabilities or a genuine increase in interstellar traffic through our solar system. Dr. Alan Fitzsimmons from Queen's University Belfast notes that statistical models predicted we should encounter one interstellar object every few years, yet the diversity among our 3 visitors exceeds all theoretical expectations. This pattern has prompted astronomers to reconsider whether we're witnessing random cosmic wanderers or something more systematic. The progression from Oumuamua's mysteries to 3I Atlas's apparent technological signatures suggests an escalating complexity that challenges conventional explanations for these cosmic visitors. James Webb's metallic discovery. Despite its immense size, 3I/Atlas exhibits distinctly metallic characteristics not commonly observed in natural celestial bodies traveling through space. Recently, the James Webb Space Telescope captured unprecedented infrared images revealing highly reflective surfaces and spectral signatures indicative of engineered materials rather than typical rocky or icy compositions. Dr. Jane Rigby from the Space Telescope Science Institute leads the comprehensive analysis of these groundbreaking findings that challenge conventional understanding of interstellar objects. The spacecraft's sophisticated instruments detected unusual heat emission patterns consistent with metallic alloys and composite materials rather than the typical signatures expected from cometary ices or rocky asteroids. These observations fundamentally challenge conventional cometary models and provide compelling evidence supporting theories about the object's potential artificial origin. The metallic properties suggest advanced engineering capabilities far beyond current human technology, with surface materials that appear designed to withstand the harsh conditions of interstellar space. The discovery has prompted intense international collaboration, as scientists attempt to understand how such materials could survive millions of years of cosmic radiation and micrometeorite bombardment during the object's journey between star systems. The machine that steers itself. Detailed tracking of 3I/Atlas reveals subtle but unmistakable evidence that it actively maneuvers through space, strongly suggesting the presence of an autonomous guidance system. Dr. Amir Siraj from Harvard University highlights observational data showing minute trajectory corrections that cannot be explained by gravitational influences or solar radiation pressure alone. These course adjustments occur with mathematical precision, indicating sophisticated onboard navigation capabilities. Experts hypothesize the presence of an advanced propulsion mechanism or intelligent navigation system actively controlling the object's path through our solar system. Such self-steering capability would represent a technological achievement far beyond anything in humanity's current arsenal, suggesting engineering by a civilization with capabilities we can barely comprehend. The subtle nature of these adjustments indicates a system designed for stealth and efficiency, rather than dramatic maneuvers. Analysis suggests the object may be following a predetermined flight path, possibly executing a systematic survey of our solar system's major bodies. This revelation intensifies scientific debates about whether 3I/Atlas represents a natural interstellar object, or an intelligently designed probe conducting reconnaissance of our cosmic neighborhood, with sophisticated artificial intelligence guiding its every movement. Information blackout. In recent months, astronomical observations of 3I/Atlas have been plagued by mysterious communication disruptions that some scientists describe as an emerging information blackout. Data streams from major observatories occasionally suffer unexplained interruptions, creating frustrating gaps in the continuous monitoring required for comprehensive analysis. Dr. Sarah Seeger from the Massachusetts Institute of Technology warns that these systematic blackouts are hindering critical data collection during the object's closest approach to Earth. The disruptions appear to follow patterns that cannot be attributed to equipment failures or atmospheric conditions, leading to speculation that the object may employ active measures to obscure detailed observation. Information loss challenges astronomers to devise innovative observational strategies and backup systems to maintain contact during the object's rapid transit. Some researchers theorize that 3I/Atlas possesses adaptive countermeasures designed to limit scrutiny from potential observers. The timing of these blackouts often coincides with moments when the most sensitive instruments would normally capture their highest quality data. This phenomenon has prompted the development of new redundant observation networks and the deployment of multiple independent systems to circumvent whatever mechanism might be causing these mysterious data interruptions. Adaptive shielding technology. Scientists, have developed theories suggesting that 3I/Atlas employs some kind of sophisticated adaptive shielding technology to survive the extreme conditions of interstellar space over, potentially millions of years. Dr. Monica Grady from the Open University explains that such advanced shielding systems might dynamically protect the object from cosmic radiation, solar particle streams, and micrometeorite impacts while maintaining its structural integrity. Evidence from variable brightness patterns and sophisticated thermal management systems supports this revolutionary hypothesis about the object's survival mechanisms. Now, these adaptive shields would enable prolonged operational capability during close stellar encounters, making the object far more than just a simple interstellar comet. If this theoretical technology is confirmed through continued observation, it would, quite frankly, fundamentally revolutionize human understanding of materials science and extraterrestrial engineering capabilities. The shielding appears to respond to environmental changes, adjusting its properties based on local radiation levels and particle densities. Such technology, well, it would require advanced sensors and automated response systems working in perfect coordination. The implications extend far beyond just academic interest, suggesting that 3I/Atlas represents an engineering achievement that could provide blueprints for humanity's own future interstellar missions. Understanding these protective mechanisms could unlock secrets essential for our survival during extended journeys between star systems. The Ancient Probe Network. So, recent theoretical frameworks propose that 3I/Atlas represents a component of an ancient probe network designed to systematically explore and monitor galactic environments across vast timescales. Dr. Frank Drake, founder of modern SETI research, has discussed the possibility of coordinated reconnaissance systems deployed by advanced civilizations to study emerging planetary systems throughout the galaxy. These theoretical probes might maintain communication through quantum entanglement or, other exotic mechanisms currently beyond human technological comprehension. Evidence suggests such a network could have been deployed millions or even billions of years ago by a highly advanced civilization with capabilities spanning galactic distances. The probes would operate with extreme longevity, possibly self-repairing and adapting to changing cosmic conditions over geological timescales. Exploring 3I/Atlas might offer unprecedented insights into this enigmatic interstellar monitoring system and reveal the intentions of its creators. The network hypothesis explains the increasing frequency of interstellar visitors and their apparent technological sophistication. Such a system would represent the ultimate expression of scientific curiosity and technological achievement, allowing a civilization to study the development of life and intelligence across thousands of star systems simultaneously, while, remaining largely undetected until their technology is sufficiently advanced for meaningful contact. Prime numbers in heat signatures. Scientists analyzing thermal emissions from 3I/Atlas have detected periodic fluctuations that correspond remarkably to prime number sequences, creating patterns unlikely to arise from any known natural process. Dr. Seth Shostak from the SETI Institute emphasizes that such mathematical precision in thermal signatures strongly indicates intentional signaling by an intelligent source rather than random physical phenomena. The presence of prime-numbered cycles in heat emissions represents a form of universal mathematical communication that any technologically advanced civilization would recognize. These observations add compelling evidence to theories that 3I/Atlas harbors sophisticated technological features specifically implemented to communicate or encode information for other intelligences. The mathematical precision of these thermal patterns suggests deliberate design rather than coincidental physical processes. Researchers are working to decode these numerical sequences, hoping they might contain more complex information about the object's origins or mission. The use of prime numbers as a communication method demonstrates sophisticated understanding of mathematics as a universal language. This discovery represents potentially the first confirmed technological signal from an extraterrestrial source, marking a watershed moment in humanity's search for cosmic intelligence and fundamentally altering our understanding of our place in the universe. We were never the observers. The accumulating evidence surrounding 3I/Atlas fundamentally challenges humanity's assumption that we are the primary observers of cosmic phenomena. Dr. Avi Loeb from Harvard University argues that this interstellar visitor demonstrates clear evidence of extraterrestrial intelligence actively monitoring and studying planetary systems throughout the galaxy. Observational data suggests these cosmic visitors are neither passive wanderers nor accidental tourists, but may represent fundamentally proactive agents in galactic scientific endeavors. This paradigm shift forces humanity to reconsider our place in the cosmic hierarchy and acknowledge the possibility that we have been subjects of study rather than the sole investigators. The revelation that advanced civilizations may have been observing Earth for extended periods alters philosophical and scientific perspectives about human uniqueness and cosmic significance. The systematic nature of these visits suggests a level of galactic organization and scientific methodology that honestly dwarfs human capabilities. Recognition that we may have always been monitored by superior intelligences challenges anthropocentric worldviews and demands humility in our cosmic perspective. This discovery marks the beginning of humanity's true integration into a galaxy populated by intelligence far exceeding our own technological and scientific achievements. The remarkable data captured by the James Webb Space Telescope has propelled humanity into a new era of cosmic discovery and understanding. As the secrets of 3I/Atlas continue to unfold, we find ourselves confronting the profound possibility that we are not alone in the universe. The ongoing study of this extraordinary visitor challenges our fundamental notions of life, technology, and our place in the cosmos. Stay with Stellar Tech as we continue following these groundbreaking developments, seeking truth among the stars, and preparing for humanity's next chapter in cosmic exploration. What if I told you that in 2017, something from another star system visited our solar system, and one of Harvard's top scientists believes it might have been sending us a message? Oumuamua, the first confirmed interstellar visitor, has sparked the most controversial debate in modern astronomy. When Joe Rogan sat down with physicist Avi Loeb, the conversation revealed shocking theories that challenge everything we thought we knew about our cosmic neighborhood. Today, we're diving deep into the mystery that has scientists questioning whether we've already encountered alien technology. The discovery that changed everything. October 19, 2017, marked a historic moment that most people completely missed. On that day, astronomers at the Pan-STARRS telescope in Hawaii detected something that shouldn't exist, an object moving through our solar system at impossible speeds, following a trajectory that proved it came from another star system. Named Oumuamua, meaning messenger from afar arriving first in Hawaiian, this mysterious visitor was unlike anything scientists had ever encountered. The object was traveling at 196,000 miles per hour, far too fast to be captured by our sun's gravity. Its hyperbolic trajectory confirmed what seemed impossible. We were witnessing humanity's first confirmed interstellar visitor. What made this discovery truly extraordinary wasn't just its origin but its timing. Astronomers estimate that interstellar objects like Oumuamua pass through our solar system about once per year, but they're typically too faint and fast to detect. Only recently had our telescopes become powerful enough to spot such visitors. The fact that we caught this one suggested either incredible luck or that these objects might be more common than previously thought. Within days of its discovery, Oumuamua would reveal characteristics that would divide the scientific community and spark debates that continue today. An object unlike anything we've seen. The more scientists studied Oumuamua, the stranger it became. This wasn't just another space rock. It was something that defied every category astronomers had for celestial objects. The object's shape was the first major anomaly. Based on how its brightness changed as it tumbled through space, scientists calculated that Oumuamua was extremely elongated, roughly 10 times longer than it was wide. To put this in perspective, imagine a cigar that's 1,300 feet long but only 130 feet wide. No asteroid or comet in our solar system has ever been observed with such an extreme aspect ratio. Even more puzzling was its behavior. As Oumuamua rotated every 7.3 hours, its brightness varied by a factor of 10, the most dramatic brightness variation ever recorded for a natural space object. This suggested either an incredibly unusual shape or surface properties unlike anything in our cosmic neighborhood. The object's reddish color, similar to objects in the outer solar system, indicated it had been wandering through interstellar space for hundreds of millions of years, its surface reddened by cosmic radiation. Yet despite this ancient journey, Oumuamua showed no signs of the dust or gas emissions typical of comets when they approach the sun. The acceleration mystery that baffled scientists. Just when astronomers thought they understood Oumuamua, the object delivered its most shocking surprise. It was accelerating away from the sun in a way that gravity alone couldn't explain. This non-gravitational acceleration was subtle but unmistakable. As Oumuamua sped away from our solar system, it was moving faster than it should have been based purely on gravitational calculations. For comets, this kind of acceleration is normal. Ice vaporizing from their surface creates a rocket-like effect. But Oumuamua showed absolutely no signs of cometary activity. The acceleration was consistent and measurable, ruling out random forces or measurement errors. Something was pushing Oumuamua, but what? Traditional explanations fell short. The object was too small for solar radiation pressure to account for the observed acceleration, and it lacked the outgassing that typically propels comets. This mysterious acceleration became the smoking gun that would fuel the most controversial theory in modern astronomy. If natural explanations couldn't account for Oumuamua's behavior, what could? The answer would come from an unexpected source: Harvard's Department of Astronomy, where one physicist was willing to consider possibilities that others dismissed as impossible. The stage was set for a scientific revolution that would challenge our understanding of our place in the universe. Avi Loeb's revolutionary theory shakes science. When Harvard physicist Avi Loeb appeared on Joe Rogan's podcast, he dropped a bombshell that sent shockwaves through the scientific community. Oumuamua might be artificial technology from an alien civilization. Loeb, former chair of Harvard's astronomy department, wasn't some fringe theorist. He was a respected scientist with hundreds of published papers, who had simply followed the evidence to its logical conclusion. Just like Sherlock Holmes, I follow the evidence, trying to find the solution. The physicist's theory centered on one key insight: Oumuamua's unusual properties perfectly matched what engineers would design for an interstellar light sail. Its extreme thinness would minimize damage from interstellar dust, while its flat geometry would maximize surface area for solar radiation pressure. Exactly what would propel a light sail through space? Loeb's calculations showed that solar radiation pressure could indeed account for Oumuamua's mysterious acceleration, but only if the object was incredibly thin, like a sheet of paper tumbling through space. This wasn't just speculation, it was based on rigorous physics and observations that other natural explanations couldn't adequately address. The scientific establishment's reaction was swift and harsh, but Loeb stood firm in his assessment.
The light sail theory that changes everything.
The concept that Oumuamua could be an alien light sail isn't science fiction, it's cutting-edge physics that we're already developing here on Earth. Light sails work on a simple principle. Photons from stars carry momentum that can push extremely thin reflective surfaces. Just as wind pushes a ship's sail, starlight can propel a spacecraft equipped with a large, lightweight sail. The technology is so promising that organizations like Breakthrough Starshot are developing light sail probes to reach nearby star systems. Oumuamua's behavior perfectly matched what scientists would expect from a light sail. Its acceleration was consistent with solar radiation pressure acting on a thin, flat object. The lack of outgassing made sense because artificial objects wouldn't contain volatile materials that vaporize near the sun. Even its tumbling motion resembled how a damaged or derelict light sail might behave after millions of years in space. Maybe it was just alien craft technology that unintentionally lost itself, like space junk. Loeb suggested, making the theory seem less threatening and more plausible.
The search for alien signals begins.
The possibility that Oumuamua might be artificial technology triggered the most intensive search for alien signals in modern history. Breakthrough. Listen, the world's most comprehensive SETI program immediately turned the massive Green Bank telescope toward Oumuamua. If the object was indeed artificial, it might be transmitting signals, either intentionally or as electromagnetic leakage from its systems. The search was unprecedented in its scope and sensitivity. Over multiple observation sessions, the telescope scanned billions of radio frequencies, recording a staggering 90 terabytes of data, enough to fill 23 high-end computers. The observations covered different phases of Oumuamua's rotation, ensuring that any potential signals from different parts of the object would be detected. The sensitivity was remarkable. At Oumuamua's distance, the telescope could have detected a signal as weak as a cell phone transmission. If alien technology was aboard this mysterious visitor, we would have heard it. The results were both disappointing and reassuring. No artificial signals were detected from Oumuamua. The object remained silent as it tumbled through space, offering no direct evidence of alien technology. However, the absence of signals didn't disprove the artificial hypothesis. A derelict piece of technology wouldn't necessarily be transmitting.
Why natural explanations fall short.
The scientific community's resistance to Loeb's alien hypothesis led to, well, increasingly creative attempts to explain Oumuamua through natural processes, but each explanation just seemed to create new problems. One theory suggested that Oumuamua was a hydrogen iceberg, basically a chunk of solid hydrogen that would sublimate near the sun, causing the observed acceleration. But, solid hydrogen couldn't actually survive the millions of years needed for interstellar travel, and the object didn't show any of the expected hydrogen emissions. Another proposal claimed Oumuamua was a fragment of a disrupted comet, but this idea couldn't account for its extreme elongation or the lack of any cometary activity. Some scientists even suggested it was a dust bunny, meaning a loosely bound collection of particles, but an object like that would have been torn apart by tidal forces during its close approach to the sun. The most recent theory proposed that Oumuamua was made of nitrogen ice, kind of like Pluto's surface. While this could maybe explain some of the observations, it would require the object to have originated from a Pluto-like world in another star system, which is, honestly, itself a pretty extraordinary claim. So, each natural explanation required increasingly exotic conditions or materials, leading some scientists to start questioning whether the artificial hypothesis might actually be the simpler explanation.
The implications of alien technology.
If Oumuamua truly represents alien technology, the implications for humanity are, honestly, staggering, and fundamentally change our understanding of our place in the universe. The object's properties suggest it wasn't sent to spy on Earth or, make contact. Its trajectory showed no signs of course corrections toward our planet, and it was already leaving the solar system when we discovered it. This supports Loeb's theory that we encountered cosmic debris, the equivalent of finding a piece of alien trash just floating through space. Strangely enough, this scenario might actually be more significant than active alien contact. It suggests that technological civilizations are common enough that their artifacts regularly drift through the galaxy. If Oumuamua is artificial, it implies that advanced civilizations have been building interstellar technology for, millions of years, leaving a trail of debris in their wake. The discovery would also validate humanity's own technological trajectory. We're developing light sail technology for interstellar exploration, which suggests that this approach represents a natural evolutionary step for spacefaring civilizations. Oumuamua might be showing us our own future, a time when human-built light sails will traverse the galaxy, potentially becoming mysterious visitors to other star systems.
The race against time and distance.
One of the most frustrating aspects of the Oumuamua mystery was just how quickly the opportunity to study it disappeared, highlighting the challenges of investigating interstellar visitors. By the time scientists realized Oumuamua's true significance, it was already racing away from the sun at, honestly, incredible speed. The object was moving so fast that no existing spacecraft could catch up to it for a closer look. Even our most powerful rockets would have taken decades to reach Oumuamua, and by then it would be way too far away to study effectively. This time, pressure forced astronomers to make critical observations with ground-based telescopes while the object was still detectable. Every day that passed meant Oumuamua was getting fainter and harder to observe. The window for detailed study lasted only a few months before the object became too distant for meaningful analysis. The experience taught scientists some valuable lessons about preparing for future interstellar visitors. New detection systems are being developed to spot such objects earlier, giving researchers more time to study them. Space agencies are also considering rapid response missions that could be launched quickly to intercept future visitors before they escape our solar system.
What Oumuamua means for the future.
Oumuamua's brief visit has, without a doubt, fundamentally changed how we think about interstellar space and our search for extraterrestrial intelligence, regardless of whether it was natural or artificial. The object proved that interstellar visitors are detectable with current technology, opening a whole new field of astronomy. Scientists now know what to look for and have developed protocols for studying future visitors more effectively. The recent discovery of additional interstellar objects, including Comet 2I Borisov and the newly detected 3I Atlas, shows that Oumuamua wasn't a unique event. If Oumuamua was indeed artificial, it suggests that the galaxy might be filled with technological artifacts from ancient civilizations. This archaeology of the galaxy approach to SETI represents a new way of searching for evidence of alien intelligence, not through radio signals, but through physical artifacts drifting through space. The controversy surrounding Oumuamua has also highlighted the importance of keeping an open mind in science. Loeb's willingness to consider unconventional explanations, despite professional criticism, really demonstrates the value of following evidence wherever it leads. As we continue to develop our own interstellar technology, Oumuamua serves as a reminder that we might not be alone in this cosmic endeavor. From its mysterious acceleration to its impossible shape, Oumuamua challenged everything we thought we knew about our cosmic neighborhood. Whether it was a natural phenomenon or humanity's first encounter with alien technology, this interstellar visitor opened our eyes to possibilities we never imagined. As Joe Rogan and Avi Loeb showed us, sometimes the most extraordinary explanations deserve serious consideration. The truth about Oumuamua may remain a mystery, but its impact on science and our understanding of the universe will last forever. Thanks for watching Stellar Tech, and don't forget to subscribe for more cosmic mysteries. A cosmic alignment so perfect it defies chance, or a deliberate arrival we were never meant to see. On September 12, 2025, astronomers witnessed the impossible. Two colossal objects arriving from opposite ends of the universe, set to rendezvous in our solar system during a total observation blackout. The official story is twin comets, but the evidence points to something far stranger. Let's explore this together. Swan's dramatic arrival. What does it look like when the impossible streaks across the sky? On September 12, 2025, we found out. The SWAN instrument, a solar wind anisotropy sensor aboard the SOHO spacecraft, flagged a new object blazing a path through the inner solar system. The first data sets, analyzed by teams led by SOHO project scientist Bernhard Fleck, were staggering. The object possessed a tail stretching nearly 2.5 degrees across the sky, about 5 times the width of a full moon. To put that in perspective, a tail of that magnitude suggests a hydrogen outgassing rate hundreds of times greater than a typical long-period comet. Its initial brightness was clocked at magnitude 7.4, luminous enough to be seen with backyard telescopes from a distance of over 150 million kilometers. This wasn't some faint smudge, this was a spectacle. News ignited across astronomy networks, and just 2 days later an amateur observer captured a jaw-dropping image showing a streak so immense it barely fit the camera's frame. It was too big, too bright, and its trajectory was already looking far too precise. The raw energy output required to generate such a visible display at that distance was the first red flag that this was something entirely new. Official recognition and growing mystery. A name makes it real but can also deepen the mystery. By September 13th, the International Astronomical Union's Minor Planet Center made it official, designating the object C/2025 R2 or SWAN in honor of the instrument that found it. Within a single weekend, the global astronomy community, from professionals using the Hubble Space Telescope to amateurs in their backyards, was completely fixated on this celestial titan. They traded images and brightness measurements across hemispheres, trying to make sense of its unprecedented behavior. Most comets discovered in the modern era are faint smudges requiring powerful telescopes, but SWAN was a spectacle for anyone who knew where to look. Its magnificent tail sliced through the constellation Virgo at a blistering pace of 20 arc-seconds per minute, growing brighter with each passing day as it raced toward the sun. The conversation quickly shifted from simple observation to intense speculation, with astronomers like Dr. Robert Warwick, the discoverer of Oumuamua, noting the statistical improbability of such a bright object appearing with so little warning. The amateur community, often the first to notice unusual behavior, was already debating what could possibly power a tail this long and this bright. It was simply too big, too vivid, and too fast to be ignored. The cosmic coincidence. Some things are so unlikely they stop looking like a coincidence. C/2025. R2. SWAN is not the only strange visitor this October. Days before, another object, 3I/Atlas, was already inbound from a completely different part of the sky. Imagine a celestial map. SWAN's path traces back from Aquarius while Atlas entered from the direction of Sagittarius. Yet both are set to reach their closest pass by the Sun within the same 10-day window. For Atlas, that's October 17th at a distance of 1.36 AU. For SWAN, it's just 3 days later, around October 20th, at a much closer 1.0 AU. Their perihelion points are separated by only about 50 million kilometers, closer than Mars ever gets to Earth. The geometry is what's truly stunning. Both are on steeply inclined orbits, with Swan's path tilted more than 60 degrees and Atlas nearly 90 degrees to the ecliptic plane. As orbital dynamicist Paul Wiegert would tell you, the statistical probability of this kind of synchronized arrival from such different trajectories is infinitesimally small. It's a corridor in space-time that seems to have been deliberately targeted. This is not random chance, it is a rendezvous. Atlas breaks the rules. So what happens when an object refuses to follow the laws of physics as we know them? 3I/Atlas first caught astronomers' attention by breaking all the rules. Early spectrographs from the Atacama Large Millimeter Array reported something that really set off alarms: a body dominated by nickel with virtually no iron, a ratio that's just unheard of in natural celestial objects. This, honestly, contradicts everything we know about comets and asteroids, which almost always contain iron-nickel blends, similar to chondritic meteorites. The claim was so radical that some labs immediately called for data re-verification. The mystery only deepened when its coma was found to be pumping out carbon dioxide, detected at a strong 4.3 micron spectral line, at rates 5 times higher than water. But what really couldn't be explained was its motion. Observers noted 3 distinct non-gravitational accelerations, each providing a delta V of several meters per second. These weren't the gentle pushes from solar heating, they were sharp, sudden bursts, almost as if the object had fired a thruster. The only other object that showed similar acceleration was Oumuamua, but as Harvard astronomer Avi Loeb pointed out, the pulses from Atlas seemed far more controlled and powerful. Swan, the fortress. If Atlas is a nimble drone, then Swan is a battleship. The scale of C/2025 R2 is, honestly, hard to comprehend, but it's the data that paints a radical picture. One that has driven speculators like Harvard's Avi Loeb to consider similar theories for other objects. It all began with reflectance data. Swan's core has an albedo or reflectivity far higher than a typical dark comet nucleus, matching the signature of polished metal. Some analysts even argue it fits a nickel-cobalt blend, an alloy used for its immense strength. Then came reports of a silvery halo around the nucleus, an anomaly some interpret as a plasma envelope or an electromagnetic shield. This is where it earned the nickname, the Fortress. Unlike Atlas, Swan appears steady and invulnerable, refusing to fragment as it nears the sun. Even its tail shows evidence of micro-thrusts, tiny rhythmic pulses at a consistent frequency that defy natural outgassing. Add in its 22,554-year orbit, and you have an object that appears to be ancient, armored, and on a deliberate, powered course. It isn't just passing through, it's arriving. Mission theories. Coincidence or a coordinated mission? When a long-period object on a 22,554-year cycle and a hyperbolic interstellar object arrive together, the odds of chance really plummet. This has fueled a wave of mission theories. The first, and most routine, is a scheduled refueling run, with the sun acting as a cosmic pit stop for 2 engineered probes. A second, less peaceful theory suggests an intervention or a confrontation, especially given the incredible power levels required for their observed accelerations. A third theory, championed by thinkers like Dr. Avi Loeb, proposes an audit chain. Oumuamua, or 1I/2017 U1, was the first scout, followed by 2I/Borisov, and now Atlas and Swan represent escalating responses to Earth's century of radio transmissions. Each new arrival would be a more complex probe sent to check in. In every scenario, the sun isn't just a backdrop, it's the rendezvous point, the power source, and the beacon. The idea of using a star for a gravitational assist or energy top-up is standard practice for our own probes, like the Parker Solar Probe, making this theory, honestly, chillingly plausible. Ancient connections. An orbit of 22,554 years is, well, a link to a different chapter of human history. The last time Swan would have passed was around 20,000 BCE, right at the peak of the last glacial maximum. This is where the story connects to Göbekli Tepe, a site in Turkey built around 9500 BCE. Researcher Martin Sweatman has proposed a pretty controversial theory that its pillars are actually an astronomical observatory, recording a cataclysmic comet impact that triggered the Younger Dryas climate shift. He argues that Pillar 43 specifically tracks a long-period celestial object. Mainstream archaeologists, including the site's original lead excavator Klaus Schmidt, strongly disputed this, maintaining the carvings are symbolic, Still, the timing is, hard to ignore. If Swan is on a recurring path, its last visit coincided with a transformative period for humanity. Whether that is a coincidence or a clue remains a fiercely debated question. It adds a layer of mythic resonance to an unbelievable event, suggesting we may have seen this visitor before. The blackout window. Just as things get interesting, the lights go out. From October 8th to 18th, both Swan and Atlas will pass through solar conjunction, meaning the sun's glare makes them impossible to observe for optical telescopes on Earth. This affects every major observatory, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, as the objects will be within a solar elongation angle of fewer than 5 degrees. This is a normal astronomical occurrence, but honestly the timing is incredibly convenient. Rumors are circulating of internal memos from agencies like US Space Command and the European Space Agency, directing teams to suspend high-resolution imaging. Proposals for alternative observation methods have allegedly been denied and raw data requests delayed. A handful of telescope allocation reviewers speaking off the record have described explicit orders to avoid public statements. The result is a forced silence at the exact moment when the two most anomalous visitors in modern history make their closest approach, leaving a frustrating and highly suspicious gap in the data. Underground resistance. When the official channels go dark, the people build their own. The blackout order may have silenced major observatories, but it ignited a firestorm in the amateur and independent astronomy communities. Veteran tracker Bill Gray put out a call to arms across public forums. Keep your scopes on the sky, log everything, and share the raw data on open-source servers. A distributed web of astronomers with powerful 14 and 20-inch telescopes answered. Collectives like the Ibero Tracker Group in Europe began pooling their photometric and astrometric data feeds. Leaks suggest plans to use radio telescopes to pierce the solar glare. This grassroots effort has become the only real-time source for what might happen during the blackout. It's honestly a powerful narrative of decentralized science, a global network ensuring no data disappears. When Swan and Atlas re-emerge, the first images confirming their post-perihelion behavior might come from a garage, not a government lab. This has become a testament to citizen science. Power estimates and implications. Let's talk about the energy, because, wow, the numbers are staggering. The biggest red flag for both objects is the power source required to explain their behavior. If the observed accelerations of Atlas are indeed powered by thrusters, the energy output would need to be on the order of 10 gigawatts. That's the equivalent output of 10 large nuclear power plants like the Palo Verde generating station. But Swan makes that number look insignificant. Based on its size, brightness, and the micro-thrusts detected in its tail, the most extreme estimates place its power output at a mind-boggling 10,000 gigawatts, or 10 terawatts. That is more raw power than the entire energy grid of planet Earth combined. From a physics perspective, as noted by futurists like Dr. Michio Kaku, such energy control would place its creators firmly on the Kardashev scale as a Type 1 or even Type 2 civilization. These figures push the conversation beyond academic debate and into a realm that, honestly, forces us to question everything we thought we knew about our place in the universe. The facts are as clear as they are unnerving. Two anomalous objects, defying all statistical odds, have entered our solar system on a synchronized path. One appears to be a powered drone, the other an armored fortress. They are scheduled for a close encounter during a 10-day window where they will be conveniently hidden from our best telescopes by the sun, accompanied by an official, top-down order for radio silence. This has forced the search for answers into the hands of a global network of citizen scientists. Are we witnessing a cosmic accident, a pre-planned mission, or something else entirely? Whatever the truth is, we are about to find out. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching Stellar Tech.